Welcome to the Software People Stories. I'm Shiv.
I'm Chitra.
And I'm Gayatri.
We bring you interesting, untold stories of people
Associated with the creation
or consumption of software-based solutions.
You'll hear stories of what worked,
and sometimes what didn't,
you will also hear very personal experiences.
and insights that would trigger your thoughts
and inspire you to do even greater things.
Before we jump into today's conversation, a special thanks to PM Power Consulting for encouraging and supporting this show right from the start. With over 1,000 person-years of collective experience, PM Power has helped many organizations, teams, and individuals chart out their own journeys of excellence and make progress. Thank you, PM Power. Now, let's move to today's episode. I continue my conversation with Sophia Willows, the head of engineering at RAI, an A16Z-backed developer tool startup, making APIs for online commerce. At RAI, Sophia shapes the technical direction of the company and is responsible to build a high-performance engineering culture. In this part, Sophia discusses the challenges of creating consistent and user-friendly APIs. She emphasizes the importance of involving developers early in the design process, using clear and consistent documentation, and leveraging tools like GraphQL to enforce structure and consistency. The conversation then shifts to the impact of AI on the future of software development. While AI can automate certain tasks, it's unlikely to replace the need for human creativity and problem-solving skills. Sophia encourages developers to focus on higher-level thinking and domain expertise, which are areas where AI is less likely to make significant inroads. Finally, Sophia addresses the issue of burnout and the importance of finding sustainable work-life balance. She suggests that developers should identify what energizes them and focus on those activities, whether they are technical or non-technical. By understanding their own motivations and setting realistic expectations, developers can thrive in the ever-evolving field of software engineering. Listen on. When you are developing APIs and when you're creating solutions for developers, you are part of the ecosystem, but you're probably somewhere in between. But the user experience would be largely influenced by the last mile. Even if there are UX experts who are saying how, say, login should happen or how transaction should happen, the understanding of the developers to use your APIs, plus many times developers may not be using only one set of APIs. And some of these from different publishers could follow slightly different, say, models, whether it is in terms of error logging or in terms of how you can do things and all that. So how do you enable your customers as the developer community to understand your APIs better and leverage or get the maximum benefit out of that?
Yeah, totally. This is a great question because just like thinking about that developer experience versus user experience sort of comparison. In the field of user experience, we have well-known sort of standards and best practices like the Nielsen Group's user experience design heuristics. And this is a set of, I think, 10 principles that are a little out of date at this point. They were sort of brought about in the days when desktop computers were all anybody ever used. They're not quite so up to date for mobile phones, but they're still generally applicable and generally good ideas. And anybody working in sort of the product design space will have seen these design heuristics at some point over the course of their career if they didn't see it during school. I personally saw these during school, even as a software engineer. They're very, very well understood in our field. there's no real equivalent to these for developer experience. There's no like one sort of set of 10 or 12 rules that you can refer to and sort of tick off on a checklist and say, okay, we did this, like we're probably in a good position. A lot of sort of what makes for a great API design is really, really subjective, and we don't have a great way of sort of uh, creating really nice universally applicable rules. So people might point, for instance, if you ask like, what is an example of a great API? People point to Stripe, who do payments infrastructure. Like they're always the go-to. Everyone knows that Stripe has a great API. People will point at Twilio, which do, text messaging, like they have a great API as well. But try to get someone to explain like, well, why is this a great API? What are the 5 sort of learnings we can take here and apply to any other API? It's a lot harder. So a lot of this is it's an art form, and it's not a precise science. One of the things that we try to do here is like we try to get developers involved very early. So we'll say, hey, we're thinking of building this feature. Here's how we are thinking of structuring it in our API. What do you think? And we'll get their perspective. And we're sort of in a good position where we are not just, if you think about sort of a team building a consumer app, like you're just one team. We're we're in the privileged position of being able to talk to many, many, many engineering teams that are building on top of our API and getting their diverse perspective on how does this proposed design look and feel. So this is one tool we have available to us. Like we have this audience of developers who are invested in our success, and they are motivated for our API to be as easy to use as possible, and we can lean on them. We also do a bunch of internal dog fooding. Like we generally have a very high bar for talent. We hire very good engineers who have a high degree of sort of sophistication. And so we'll try to build out this little API feature as a proof of concept, and then we'll try to build a product on top of that API feature and feel like, okay, were there any sharp edges here? Was anything very surprising? If we are getting surprised by things as the people building the API, like someone else is definitely going to get surprised here. And the other sort of thing we look for is we want internal consistency, right? So you were saying different API providers have different ways of representing errors, or they have different terminology, or if you're in like REST land, like some people will use different HTTP verbs for different things. Internal consistency is a really big thing for us. Even if our API looks and feels slightly different from the 7 other APIs that people are integrating with, we want Rise API to always feel like Rise API whenever you're using it, regardless of the feature. That way you just have to learn our API once rather than learning it 3 times for 3 different features. So we have very strict review processes in place to make sure that we're using consistent terminology. We're formatting our fields similarly. We're applying the same sort of like design principles across our API. The other thing is, and I just published a blog post on our website about this, we're using GraphQL as our API technology of choice rather than something like REST. And I think GraphQL has not been very popular in the space of like building a public-facing API with it that you ship to other companies. It's always been REST as the go-to here. You generally see GraphQL used in like enterprises, like as an API gateway that sort of merges all of your internal APIs behind one facade. But the thing that's really nice about GraphQL, and the thing that a lot of people hate about GraphQL, is that it has a lot of this this opinionated design built in from the start. So with REST, you can just write code, ship an endpoint, and be done with it. there are no rules constraining you. With GraphQL, you're forced to write a schema that describes like what type of data you take, what type of data you return. And at runtime, when the API is executing, GraphQL is verifying everything that comes in against that schema, verifying everything that goes out against that schema. It's impossible for your actual API behavior to differ from that schema. Whereas in REST, you're not required to have a schema. Even if you write a schema, there's nothing requiring you to validate your incoming payloads and outgoing payloads against that schema. It's all locked in. And people don't like this about GraphQL because there are all these rules and constraints in place which you need to contend with. Whereas REST, it's very easy to get going. You can just write code, ship it. But personally, huge fan of these constraints. Like, I think constraints are really important because they force you into building something that behaves more consistently because you must obey these rules. And our API at sort of, a 1,000-foot view looks and feels and behaves similarly to other APIs that are using GraphQL. So for instance, Shopify is also in the e-commerce space, and they too use GraphQL. So a lot of people integrating with Rai, they have some understanding of the e-commerce space. They may have tried using Shopify's APIs in the past, which is all GraphQL and follows, so they have the same base level of constraints that Rai has. They come to Rai and it feels sort of vaguely familiar because we're using the same technology, because we have these constraints. And my sort of prediction is that over the long run, like, we're going to see a lot more developer tooling companies building APIs using GraphQL because it enables much more fungibility of APIs and it gives you this sort of common base to build off of. And things like errors are represented consistently between API vendors, as opposed to the more traditional choice of REST, where it's really up to the API designer to decide like what they want this to look like.
Yeah, that's interesting because there is this perception that a large number of developers do not want to read manuals. Right? Just jump and then start coding and figure out now what happens. Let's see it. So does this approach kind of mitigate some of those kind of risks?
Yeah, to an extent, like, I mean, if I buy sort of a new microwave, right, like, I don't bother looking at the instruction manual for it because I know that like this microwave is probably going to work very similarly to every other microwave I've ever had before, right? This hasn't been true for software. Like, if you're interfacing with Zero's API versus Stripe's API versus Dropbox's API, these are all radically different integration stories because, again, when you design with REST, you start from a completely empty canvas and there's no sort of rules or constraints. There are some there are some unofficial documents that you could follow. So I think Microsoft's APIs all follow this best practices document called, I want to say it's OData, but I could be wrong. And so, if you're interfacing with 5 different Microsoft APIs, they'll all look and feel somewhat similar. But again, the moment you step out of that and need to integrate with a different vendor, you're learning from scratch all over again. And so this is a big problem, especially in today's world where, honestly, like, a lot of software engineering today is a matter of stitching different API providers together or gluing different software modules together. So if you have 5 or 6 systems you need to integrate with in order to build a feature, like at Crimson, we built an AI chatbot to automate some of our customer support burden. And we had to integrate with, our email provider. We had to integrate with our live chats provider. We needed to integrate with our help center so we could pull documents in to train our AI with. We had to integrate with large language model providers like OpenAI. We had all kinds of AWS APIs we had to integrate with. And all of these things, radically different in every single possible way. But yeah, with GraphQL, we're a little closer to that dream of, you buy a microwave and it works similarly to every other microwave you had, because things like how you model errors or the types of data supported by the API, these kind of things are specified ahead of time before you even start building your GraphQL API. And if you go off the beaten path, like your server just doesn't work, you're forced to meet these constraints and rules. So I think it gets us closer, but it still doesn't fully solve the problem, because there's this other sort of problem which is a lot harder, and that's like the domain knowledge piece. So even if Rise API looks and feels and behaves similarly to OpenAI's API from a technical perspective in terms of like how errors are sent over the wire or how you make API calls and things like this, even if that's true, the domain knowledge you need to build an e-commerce integration with Rise is very different from the domain knowledge you need to build some kind of AI-powered tool on OpenAI, because we're completely different sort of spaces, right? So that's a lot harder to solve. I don't know if there is a solution. I think some level of reading the manual and getting up to speed with like, okay, what is the sort of jargon of space I'm working in and this kind of stuff. I think we'll always need that to some extent, but certainly on the technical front, we can work towards eliminating a lot of the sort of variance between APIs through using things like GraphQL.
Yeah, that's interesting. When you say that the APIs from different vendors have their own probably characteristics or personalities, as the head of engineering, how do you kind of get not groupthink, but at least your team, to at least converge on some of these things and then work together in a more uniform manner?
Yeah. Well, the big one, honestly, is like, a lot of the stuff, like I don't really want the team, I want the team to be thinking about this as little as possible. So automation's a really important thing for us. So these days, like, there's kind of this like ongoing joke of like, do programmers prefer spaces or tabs? These days, like this discussion just doesn't happen. It might have happened 20, 30 years ago. I don't know. It's before my time. But like these days, every single company or 99% of companies use automated code formatting tools, and nobody gets to make the decision of whether it's spaces or tabs. Like it's just a uniformly applied standard done by software. If you violate the code formatting standard that your formatter uses, like you can't merge or change, you got to fix it. And it's all automated. So similarly for our schema, the way our API is sort of written, like wherever possible, if we can automate something, then we will. So for instance, we have a rule that all time fields in our API must end with @ and must have a type of time. It's a type we've defined in our GraphQL schema. We don't want to be returning string fields. We want to be returning time fields. And so because we have the schema and because it's all code, it's possible to build a script that takes that code, turns it into a syntax tree, and you process it, and you can create rules like, hey, if this field ends with @ like created @ and the type isn't time, throw an error, fail the build, and you can't merge or change. If something is typed as time, and in reverse, if something has a type time and the name doesn't end with that, fail the build, we have an issue here. So wherever possible, we want to be automating these things so that people don't need to invest brain power into this, and they can focus on sort of more valuable and differentiating work than following sort of like rules we put in place. Obviously, this only gets you so far. There are some things which you cannot automate. So, to sort of go a little deeper into this question of like, what do you call and type date time fields at? what happens if someone's called the field just created, right? So it doesn't end in at, not typed as time, how you fix those. Maybe one day AI gets us to the Holy Land where this is no longer an issue, but obviously at some point you need humans in the loop to be looking at these things. So one of the sort of rituals we have at Rye, two of the rituals, sorry, is every week we have a big team meeting as an engineering team. We have two different types of meeting and they alternate different weeks. One is what we call Eng Sync Up. It's kind of like an engineering all hands.
Okay.
And everyone gets together and we'll talk about, what is a design principle we want to start following? What's a best practice we want to start using? Or we'll go through some code, someone will present, and we'll take a look and just sort of realign around, how do we do work as an engineering team and sort of deepen that mutual understanding. The other thing we do is draw Rye. And so someone who is an expert on a particular part of our system will come along and give a detailed deep dive into it. Someone else on the team who isn't an expert will draw a diagram of the system as they're explaining. Because they're not an expert, sometimes there are sort of interesting mistakes that get made and it's quite funny. But we end up with like quite an interactive meeting where people are building expertise on different parts of our system and how they work and seeing how they fit into the sort of cohesive whole that we're making. And then from there, we do the typical thing, which is nobody can put code into production without it getting reviewed by another person on the team. We have standards documents internally which describe like, hey, this is how we think about our API. These are kind of like the best practices we're trying to follow. And between those two people, the person who wrote the code, the person who reviewed it, we generally end up in a good place. But the big thing is sort of, you need to keep repeating this stuff because it's so easy for things like this to slip into the background if someone's grinding on a really hard project. Like we're building a billing project right now, super complicated because it's moving, it's dealing with funds and there are all these sort of correctness requirements on our end. It's easy for these smaller things like what do we call fields or how do we think about data types, like what's our approach to modeling schemas. It's easy for this stuff to get forgotten because people are so deep into the technical challenges of their work. So it's really important to just keep repeating this stuff and keep it front of mind and make sure that it doesn't fall by the wayside.
So a related thing, is your team all located in one or a couple of adjacent time zones, or is that wider spread?
For the most part, yes. So 99% of the team is between sort of, west coast of the US through to Brazil, which is a 4-hour time zone gap. I'm the odd one out. I'm in New Zealand, and at the moment I'm 5 hours behind Pacific time. It can be anywhere, West Coast, sorry. So it can be anywhere between like 3 to 5 hours, depending on what daylight savings is doing. So yeah, no, I'm the odd one out. Every company needs one person from New Zealand, right? It's a requirement these days. But yeah, 99% of people on the team we're within
that kind of helps. Particularly on these group activities.
Totally.
Yeah, I didn't realize how much time we've been talking. But then I have to ask you a couple of things. You also touched upon your expectation from AI, what it could do for code, and then you also talked about all the IDEs and the rule enforcement happening there. With all this, and people talking about low code, no code, or now saying that I can get ChatGPT to write code for me and all that, is there a future for a developer in terms of career if someone wants to choose IT?
Absolutely. Like, I think, look, I think there are some things we can be certain about here. There are some things we can be less certain about. And I think we can be certain about the fact that AI is going to, in the short to medium term, automate away a lot of sort of grunt work that we're used to doing. So, I use Copilot when I write code, and it makes me a little bit more effective. And there are some sort of tedious tasks that it's like really, really good at, and I don't need to think about these anymore. But at least in the short to medium term, I don't see these tools solving the harder parts of the job, like designing a system, talking to customers, figuring out what they need to do, all this kind of value-added work that we do as software engineers. I don't see these tools solving that in the short to medium term. I'm less confident about this over the long term. Like maybe 100 years from now, we don't have developers, but I think people alive today, like there is definitely a career available. And I think in general, the world has unlimited appetite for software engineers. We're in a very difficult time at the moment where interest rates are very high and there have been a lot of layoffs. But I think, if we sort of zoom out on the chart and sort of look at like, what does it mean to be a software engineer? What are the characteristics of this job? There's no other career path where you, with so little schooling, like there are some people who do like a 2 or 3 week boot camp to get a job, like with so little schooling, like you can have a job with conditions as good as what we're used to in software. And so we're in a bit of a blip right now, but honestly, the going's still pretty good. And I think in some ways things will get harder because AI is going to automate away a lot of the jobs that, junior engineers might have done, and it's going to be harder to get your foot into the door in some cases. But there's a lot of work out there for software engineers, a lot of non-obvious work. A few months ago, I went on a different podcast to talk about software's role in climate change and emissions from sort of our software footprint. We need a lot of really smart software engineers to come in and make software more computationally efficient to reduce our species' impact on the planet. And I don't see AI doing this because it is so technical and hard to do. It requires very deep understanding of performance characteristics. And so I think there's a very bright future for people in IT. I think there's a lot of doom and gloom at the moment, but I think if you work hard and you want it, like there is a place for you. And I don't think we should worry too much about, what might AI do 100 years from now. I think in the next, 20, 30 years, we'll be fine. We just need to get through this current moment and we'll all be sort of happy again.
Yeah, that's pretty practical. So what about people who, say, spent about maybe 15, 20 years in the industry, either feeling overwhelmed with the rapid advances in technology or maybe feeling a little exhausted that they're trying to solve the same problems, maybe a little differently, different technologies, but underlying challenges are probably similar.
Yeah. I think it's important to stay sort of grounded, right? And it's important to understand sort of who you are and what sort of drives you and what energizes you. So what is important to you? What are the things that sort of invigorate you and make you want to do more of it versus what are the things that you do and you just kind of dislike? And I think a lot of people are kind of unclear on this. They don't understand this so well. So, I'm in a position where, I work with a lot of sort of senior engineering talent, and like practical example here is like, I will have people ask me, how do I get into blogging? Like, I've read your blog, Sophia. Like, how do I do that? I try and I can never get anything out. It's so exhausting. I don't like writing. And my advice is like, hey, like you shouldn't force it. Like, if you don't like writing blog posts, like you should find something else that you enjoy. Maybe you like doing podcasts, or maybe you like doing one-on-one mentorship, or maybe it's entirely non-technical and you want to go volunteer to soup kitchen. So the most important thing here is like if you're going through a mid-career crisis and you're not too sure about what you're doing, is you need to get specific and try to figure out like, well, why are you going through this? Like, what is causing this? Is it just because you're burned out on your tech stack? Well, that's a very easy fix. Like, try get another job or an internal transfer or work on a greenfield project where you can do something different or start a side project. If it's more sort of general, like you're just burned out by the rate of change, honestly, in that case, like the rate of change is not you need to realize that the rate of change in our industry is not going to slow down. Like the pace of technology is only increasing over time. And so if you are burned out on like just the rate of change in general and the need to constantly upskill, one option is take 3 months off, see how you feel at the end of it. But if this truly is sort of where you're at, like maybe it is time to start thinking like, okay, do I sort of pivot into something else? And one of the amazing things about being a software engineer is that if you are mid-career, if you're 20 years deep, it's probably realistic for you to do that. Like you probably have savings and investments once you're at that point. Like we're reasonably well paid as a profession, much more so than a teacher. So, you should reflect on why am I burnt out? Is it fixable? Worst case scenario, you're 20 years in and that's a pretty good run. Go do something else. Go teach people or do other sort of community projects or become an accountant. One guy, an open source maintainer, I forget his name. He got burned out. He didn't like it. He disappeared for a year. Popped up on a GitHub issue and said, hey guys, I'm not a software engineer anymore. I'm a carpenter now. I love, building stuff with my hands. This is more enriching. It's energizing me. So find what energizes you and do more of that and less of the things that are draining.
On that very encouraging note, Sophia, thanks a lot for coming on the show and then sharing your perspectives and your experience.
Yeah, thank you. Thank you so much for having me. I've really enjoyed it.
We thank Siddharth for the music and Anita for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.